All right, let's see what some of these derivative rules look like in action and combined. So if I want to find the derivative of this function p of x, how are we going to do it? Well, the derivative of p of x is p prime of x. And what that is we have to take the derivative of this whole thing. 17x to the 10th plus 13x to the 8th minus 1.8x, blah, blah, blah. I did not give myself enough room for this. And here's where the sum rule comes into play, right? We have a function here, plus a function here, plus a function here, plus a function here. We can just take each of these derivatives by themselves. That's what that rule says over here. That if you're taking the derivative of something plus something else, just take the derivatives individually. Just really nice. So really what we have here, and I don't know if I really want to write this, but I'm going to, is this is the derivative of the first guy plus the derivative of the second guy, minus the derivative of the third guy. You can see this getting a little tedious, plus the derivative of the last guy. We're only going to write this once. Okay. After letter A, I'm never writing this again. We're just going to start doing it. But I want to really technically show you what we're really doing. And now we use the constant multiple rule, right? We need to take the derivative of this first thing. That's a number multiplied by a function. And what we said, the constant multiple rule says if we're taking the derivative of a number times a function, that's just the number times the derivative of the function. So what is this really equal to? It's 17 times the derivative of the function, x to the 10th, plus 13 times the derivative of this function, x to the 8th, minus 1.8 times the derivative of this function, plus, well, this last one's a constant. What is the rate of change of a constant function? Constant functions are flat lines. The derivative of a constant is 0. We said that up at the top here. Derivatives of constant functions are 0. Technically, this is a subset of the power rule. But if you want to write a note to yourself, the derivative of a constant function is just 0, you can do that. All right. All right, great. And then we can use the power rule. We have 17 times this derivative. The power rule says if I'm taking the derivative of x to an exponent, a monomial like this, we bring down the exponent and subtract 1. N is now a coefficient. Our exponent's now n minus 1. So bring down the 10. Now the exponent's a 9, 1 smaller. Bring down the 8. Now the exponent's a 7. It's 1 smaller. We can use the power rule on this one too, actually. Bring down the exponent, which is 1. Now the power is 1 smaller. It's 0. And remember, x to the 0 is just equal to 1. So we're almost done. I almost had enough space, actually. We just simplify 170x to the 9th plus, oh dear, 104 x to the 7th, 13 times 8, I think so, minus 1.8. That's p prime. That is our derivative. That's how we do it. We are not going to be doing all these steps, okay? Usually, we're just going to be jumping straight to here. But when you're learning, it can be a great time to do all of these steps just to make sure you know exactly what's happening. But as you can see, it takes a bit of time. Letter B, we need this derivative. Before I take this derivative, I see that there's a square root, and I don't remember taking any derivatives of square roots. I also didn't haven't told you about how to take the derivative of fractions. So in here, we're going to rewrite this one first. Before we take the derivative, let's write this like that. Remember, fractional exponents are the same thing as radicals. So the square root of t is t raised to the 1/2. And then remember, negative exponents mean the exponent goes in the denominator. So t to the -4th is the same thing as dividing to the t to the 4th. Remember your properties of exponents. And now we can take the derivative because these first two use the power rule, and the last one uses what we know about exponential functions. So we can say y prime, or if you wanted to, you could think of taking the derivative with respect to t. Up here, the derivative was d dx. Down here, it'll be d dt because our variable is different. Our variable is now t. So y prime here is 3, constant multiple rule, times what's the derivative of t to the 1/2? We'll use the power rule. 1/2, and we subtract 1 from the exponent. I'll write it all out. The exponent becomes 1 smaller. -4, we use the power rule again. The exponent comes down, and the exponent gets 1 smaller. Constant multiple rule again. What's the derivative of e to the t? It's e to the t. Okay. And now we just simplify. We're done taking the derivative. We're going to get 3/2 times t to the -1/2. Right? 1/2, take away 1, you're now down 1/2. -4 times 4 is plus 16. -4 minus 1 is -5. And the last one's 5 e to the t. And this is correct, and I'll take this. But the best way to write this is rewriting this first one. Most people don't like negative exponents. We'll also rewrite the second one. The negative exponent means the t is in the denominator. And remember, an exponent of 1/2 means a square root. Lots of algebra coming back in this section, okay? So feel free to ask for a review if some of these are not familiar to you. The exponent is attached to the t. It's not attached to the 16. It would look like this if it were attached to the 16, but like this, it's just attached to the t. So the t goes in the denominator. And this is usually the nicest answer that we could give. So again, we'll do one more example. Take the derivative of this quadratic function. To be very clear what's happening between the power rule, the sum rule, and the constant multiple rule is that this is equal to 17 times the derivative of x squared minus 33 times the derivative of x plus the derivative of 12. This is really what's happening. We usually don't write this, but it's a really good idea to write this when you're still learning. So, power rule on x squared, the exponent comes down, and the exponent becomes 1 smaller. Over here, again, oh dear. The derivative of x is just 1. That's another very common one. Because of this information over here, you can also make a note to yourself that the derivative of x is equal to 1. The power rule tells us that. You don't need to write this down, but it's a common shortcut. It saves us some writing. So this will just be 33 times 1. And again, the derivative of any constant function is 0. There's a difference between constant multiple, which looks like this, 17 times the derivative, and a constant function, which is just the 12. Constant functions are flat lines. They have no slope. So we'll simplify this out and we'll get 34x minus 33. May feel unfamiliar now, but I promise you, once you've done this enough, it'll get very, very quick, especially with polynomials like this. You'll eventually just look at this and say, okay, 170x to the 9th plus 8 times 13x to the 7th minus 1.8 plus 0. And you can see that's exactly what you get. So get some practice. We got lots of videos for that specific reason, and ask questions. Bye-bye.